One way of locating something in a city, a building for instance, is to do it in terms of two streets that cross. Saying that the First National Bank is at the corner of Lincoln and Oakton locates it. A similar method is used to locate places anywhere on Earth. This system combines parallels of latitude with meridians of longitude. Before we study this system, let's review some geography. Let's look down on the Earth from above the North Pole. Our Earth is a nearly perfect sphere. We can draw circles on it. The largest that can be drawn is called a great circle. Like any other circle, it is measured in degrees. In a quarter of a circle, there are 90 degrees. In half a circle, 180 degrees. And in a full circle, 360 degrees. The Earth rotates on an axis whose ends are marked by the North Pole and the South Pole. The equator is a great circle halfway between the poles. It is the starting place for the measurement of latitude. We call it latitude 0. All places on the equator are at latitude 0. All places on this circle, which is north of the equator and parallel to it, are at 10 degrees north latitude. To see what this means, we'll cut away the Earth along a great circle that passes through the poles. The angle between the equator and the circle marked 10 degrees measures 10 degrees. 20 degrees north of the equator, we can draw another circle. All places on this circle are at 20 degrees north latitude. We can draw circles every 10 degrees north of the equator until at the North Pole we reach 90 degrees north latitude. We can mark off circles in the same way south of the equator. We call all these circles parallels of latitude. About half of the United States lies between the 30th and 40th parallels of north latitude. Parallels can also be marked for single degrees of latitude. The distance between any two parallels of latitude is the same around the Earth. 1 degree of latitude is about 70 miles wide. Using only degrees, we can locate a place within 70 miles of its actual position. To give the location of places more exactly, we divide the degree into 60 parts, each called a minute. A minute of latitude is about 1 1/6 miles wide. To locate a place even more exactly, we divide 1 minute of latitude into 60 parts, each called a second. 1 second of latitude measures about 100 feet in width. So if we know the degrees, minutes, and seconds of latitude of a place or object, like this highway bridge, then we know within 100 feet how far north or south of the equator it is. But for its east-west position, we need another set of lines. We saw that the equator is a great circle midway between the poles. Each half of a great circle that passes through the poles is called a meridian. The meridian that passes through Greenwich, England, is the starting place for our measurement of longitude. We call it the Prime Meridian. All places on this meridian are at longitude 0. All places along this meridian, 15 degrees west of the Prime Meridian, are at 15 degrees west longitude. To see what this means, we'll cut away the Earth along the equator. The angle between the Prime Meridian and the meridian marked 15 degrees measures 15 degrees. Another 15 degrees west of the prime meridian, we can draw another meridian. All places along this meridian are at 30 degrees west longitude. We can draw meridians every 15 degrees west of the prime meridian until we reach 180 degrees, halfway around the Earth from the prime meridian. In the same way, we draw meridians of longitude east of the prime meridian to the 180th meridian. If we look at a section of the full Earth between two meridians, we see the distance is widest at the equator and narrowest at the poles. 1 degree of longitude at the equator is about 70 miles wide. Halfway to the poles, a degree of longitude is only about 50 miles wide. We also divide degrees of longitude into minutes and seconds. By using both meridians of longitude and parallels of latitude, we can give the nearly exact location of this highway bridge or any other place on Earth. On a map, we often find lines of latitude and longitude drawn in. On this kind of map, a Mercator projection, meridians are not shown meeting at the poles as they really do. Suppose we wanted to give the location of Denver, Colorado. Denver is nearest to the 40th parallel north of the equator. It is west of the prime meridian on the 105th meridian. Denver is located at latitude 40 degrees north, longitude 105 degrees west. Let's locate Sydney, Australia. It is south of the equator, on the 34th parallel, and east of the prime meridian, on the 151st meridian. Its location is latitude 34 degrees south, longitude 151 degrees east. So we've seen how we use latitude and longitude to give locations of places anywhere on Earth. We also use longitude to help us set up time zones. We measure time by the turning of the Earth on its axis. The Earth rotates once every 24 hours, and 24 hours is the length of our day. Because the Earth turns, we know that at any moment, while it is night at some places on Earth, at other places the sun is rising or high overhead. The time of day everywhere on Earth is, in general, determined by the sun. As the Earth rotates, all parts of it turn through a full circle of 360 degrees every 24 hours. This means that in 1 hour, the Earth turns through 1/24th of a circle, or through 15 degrees per hour. Knowing this, we can see how the Earth is divided into 24 time zones, each 15 degrees wide. The starting place for the system of time zones is the meridian that passes through Greenwich, England, the prime meridian, longitude 0. It is the center of a time zone that is 15 degrees wide. When the sun has reached its highest point over the prime meridian, that is, when it is noon, sun time there, the time is considered to be noon across the full zone. The time in this zone is usually called Greenwich time. The 15th meridian west longitude is the center of the first zone to the west of Greenwich time. When it is noon, Greenwich time, it is 11 a.m. in this zone. Time in the second zone west of Greenwich, the zone including the 30th meridian, is 10 a.m. And so every 15 degrees of west longitude, standard time is earlier by 1 hour. Time is later in the zones east of Greenwich. When it is noon Greenwich time, in the first zone east of Greenwich, the time is exactly 1 p.m., 1 hour later than Greenwich time. and every 15 degrees of east longitude time is later by 1 hour. And so the rotating Earth has been divided into 24 time zones, one for each of the 24 hours of the day. While the time zones were planned to follow meridians, parts of the boundaries of many have been changed for convenience. We can see some of these changes by looking at the time zones of the United States. Each zone has been given a name. The eastern parts of the United States are in the Eastern Standard Time Zone. When it is noon Greenwich time, it is 7 a.m. Eastern Standard Time. At the same moment, it is 6 a.m. Central Standard Time, 5 a.m. Mountain Standard Time, 4 a.m. Pacific Standard Time, 3 a.m. Yukon Standard Time, and 2 a.m. in this zone, which has two names. In Alaska, it is called Alaska Standard Time. But in Hawaii, the same zone is called Hawaiian Standard Time. In the far western parts of Alaska, including the Aleutian Islands, it is 1 a.m. Nome Standard Time, 11 hours earlier than Greenwich time. Located in the region of the Pacific Ocean is a line generally following the 180th meridian. It has been agreed that each new calendar day begins along this line. This is the international date line. It is 1 day later on the west side of the line than it is on the east side. So if it is Monday on the east side of the line, then it is Tuesday on the west. Travelers who cross the date line from west to east repeat a day. Travelers who cross the line from east to west lose a day. So with parallels of latitude and meridians of longitude, we can give the location of places anywhere on the Earth. And from the meridians of longitude, we have the basis for a worldwide system of time zones.